Welcome to another Panther Math Corner. This is your teacher, Dr. Irvin Howard, and I want to continue our discussion, quadratic series, and this time we will be completing the square. So given the quadratic equation in form of x squared plus bx, and I want to demonstrate a few examples in completing the square. Now, as you see the given format for a quadratic equation when completing the square. Now, when finding the solutions for completing the square, you have to remember that the trinomial will be in the form of a perfect square. The middle term and the third term of the quadratic equation in form will have the same value for the middle term as well as for the last term, which is the c. But at first I want to demonstrate if it's given in a x squared plus bx form, this would be the result. You would take the b part, take half of it, and then square it, and you would get the third term, which will be the c. Okay, and I'll give you a few examples starting right now. For example, I will give you the example for x squared plus 6x. All right, you don't have a value when you start off with, but when you finish and for completing the square, you will find that a new value will be the c value. All right, so let's get started, and I'll just erase this. Move this a little bit, excuse me. All right, to solve for completing the square, you would take, now this represents bx, all right? So what we're going to do is take half of b over 2, which is 6 over 2. We do it all the time. Take half of b, and then this would be 3, and then square it. 3 squared will be 9. And then we'll just add 9. Alright? And then afterwards, we find that the same values that gives you 9 are also the same values that give you the middle term. So 9 represents a product of 3 times 3. And the same pairs of numbers will give you the sum in this case. So 3 plus 3 is 6. So I can write this as a binomial value, 3 plus x plus 3 squared. Alright, so this is the c value, which will be 9, and also corresponds with the b value, whether the b value will be the sum of the same two numbers or the difference, which case you know that it will be using the same values involved in finding the c value. Alright, let's try another one. Let's try x squared minus 9x. Alright, and I'll make the arrows to imply. Alright, like before, this represents the b, and in order to complete the square, we take half of 9. Alright, whether you take negative 9 or whichever the case, when you square it, it's going to always be a positive number for your b value, for your c value, excuse me. But in this case, I'll show you. Take 9, half of 9, which is what? 9 halves. Alright, and then square it. So this represents b over 2. Alright, so this is b over 2, 9 over 2. Let's keep it as a fraction form because we want to try to avoid expressing values that are rational numbers that are in decimal form. It's better to keep it because you'll be able to see it better in its fractional form. So we take half of 9, which is 9 halves, and then square it. This would be 81 over 4. Alright, so this would be x squared minus 9x plus 81 over 4. Alright, and then when we find the binomial form, factor form All right, what two numbers will give you 81 over 4, and the same two numbers added will give you the middle term. And this will be x minus 9 over 2 squared. All right. Okay. All right, let's try one more. All right. Let you see that. Let's try one more, and I'll erase this part right here. All right, we'll try x squared plus 10x. All right. All right. Again, we are demonstrating the form of x squared. We're demonstrating the form of x squared plus bx. All right. This is the format. So when you're given this format and completing the square, you're only finding the third term, which will be the c value. Right. In this case, x squared plus 10x, we look at the b value. We take 10 over 2, which is 5, and then square it. All right. Once we find this is the c value, we add it to the x squared plus 10x plus 25. All right. Like all perfect squares, we know that 25 represents 5 times 5, and also the same two numbers, 5 and 5, if you add or subtract, will give you the middle term. In this case, it will be a positive 5, because two positive 5s, 5 plus 5, will give you the 10. All right, so we write it as x plus 5 squared. All right. Okay, now that we demonstrated examples of completing the square in its x squared plus b form, I want to show you a few examples with x squared plus bx equals to d. That means, what if you have another value already involved with your expression? And I'll demonstrate. I'm going to erase this. Okay. All right. And let's erase all of this. And I'm going to say, given x squared plus bx equal to some d value. That means if it's already a number present after the equal sign, what do we do with it? Okay, and I'll demonstrate. For example, let's solving a quadratic equation. And thank you for your patience as I write this example. X squared minus 16x equals to a negative 15. This is nice. All right. By completing the square. Right. We'll do two examples real quick, and we'll show you, you'll use the knowledge from completing the square, all right, in solving this expression. And there may be involving extra steps, but notice it real carefully. So again, we have x squared minus 16x equals to negative 15. All right, so we're going to look at the middle term. We're going to complete the square as the last two examples. What two numbers will give you the two numbers, 16? Divide that by 2. Take half of that. All right, 16, which is the b squared over 2. This is b. Take half of 16, and then half of 16, 16 over 2 is 8, and then square it, which is 64. All right. Now, not only you have to now in parts of in the steps in completing the square, not only you add 64 on the left side of on the left side of the equation, you're going to have to add 16 on the right side of the equation, like so. X squared minus 16x plus 64 equals to negative 15 plus 64. So you're adding 64 on both sides of the equation. The first two examples, you only add it on one side, which is the C value. All right, this is the C value. All right. This time you have to add 64 in this completing the square. If you're given a D value, if it's in a quadratic equation equals to some value, then you have to add it on both sides of the equation. So what two numbers will give you 64, and the same two numbers added or subtracted will give you the middle term? We know that it's x minus, 8, and this is squared, equals to negative 15 plus 64 will be a 49. All right. Now this looks familiar territory because we have a type of binomial equation and it's squared, so we can't leave it like this. So if you remember our previous videos on completing solving quadratic equations or solving the quadratic series, you know that we can't leave this square like it is. So we have to take the square root on both sides to cancel out the square, and at the same time we're finding square roots on both sides of the equation. So we do it like this: square root both sides. All right, square root the 49. All right, so this comes out as x minus 8 equals to square root of 49 plus and minus 7. All right, that's brilliant right there. All right, so we have a equation that shows two possible real solutions, a plus and a minus. So we split those two equations for plus x minus 8 equals to a positive 7, and x minus 8 equals to a negative 7. In this case, since it's both minus 8, we add 8 on both sides so that the terms are balanced and cancel out. A negative and a positive of the same quantity will cancel out. X equals to a positive 15 because both 7 and 8 are positive. We add 8 again on both sides of this side. This would be a positive 8. And we have x. This cancels. We have x give us a positive 1. Since there's more positives than negatives, then the difference will be positive. So your real solutions are x equals to 15 and x equals to positive 1. All right. Let's try one more solution set, and we'll do something a little different so that you can see the examples real clearly. I'm going to erase this again. Okay, thank you for your patience. All right, and still we're demonstrating the squares in the form of in the form of x squared plus bx equals to d. All right, here's another example. Let's solve 2x squared plus 20x minus 8 equals to 0. All right. All right. So this is a different example. The other example shows when it equals to some d value. Now this does equal to some d value. This is 0. But we have a coefficient in front of x squared. So we need to make it look much like this. All right, x squared plus bx equals to some d value. All right, whether it's 0 or a number. All right. Once we've done that, we'll be okay. All right. So that means that we have to get this 8 on this side. So let's add 8 on both sides so that we make it look like that. All right. 2x squared plus 20x, negative and positive cancels, and adding 8 on this side will have 8 on this side. So see, it seems like, a balance. It was negative, now it becomes positive. So the signs change when we perform the properties of inequalities. And if you want to review the properties of inequality, you can go to my website, emhwebs.com/PMC2, and you can look at NC Math 1 series. All right, and I will leave the link available in the future videos. All right, so now that we have x squared, but it doesn't look like it's the x squared part, so because we have the 2, so we have to get rid of the 2. And how we can do that, we can divide everything by 2. It seems like they're divisible by 2, so let's divide 2 for everything. All right, in the equation, make this more of a 2. All right. Okay, so this cancels. We have plain x squared plus 20 over 2 is 10x, and 8 over 2 is 4. Now, it looks just like this, right? X squared plus bx equals to d. Now, we can start with completing the square. So we take b over 2, 10 is the b. All right, take half of this over 2, and then 10 over 2 is 5, and then square it, completing the square, which equals to 25. All right, let me show it to you. All right, so it equals to 25. All right, now, once we have this, we add 25 on both sides. X squared plus 10x plus 25 equals to 4, and we add 25 on this side. So we have x squared plus 10x plus 25 equals to 29. All right. So when we complete the square, what two numbers will give you 5, and the same two numbers give you 10. So we concluded x plus 5 squared equals to 29. All right. Same 25, when you multiply, 5 times 5 gives you 25. The same 5, 5 plus 5 will give you 10. And that's how we deduce that it will be x plus 5, and then it's squared. Now, we can't leave it like it is. Again, we have to perform finding the square roots on both sides. So we take the square roots on both sides. X plus 5 squared equals to, we square root 29. All right. Now, as finding the square root of x plus 5 squared, the square roots cancel out the exponents. We have x plus 5. It does it all the time. Equals to square root of 29. We have to leave it because you can't really find it, so it'll be plus and minus some square root of 29. All right. Now, this is a solution. So as a solution, that's going to be two values, a plus and a minus. So we have to solve for x. Let's subtract 5 on both sides. All right. There's no way that we can add and subtract negative 5 to that 29 because this is the square root of 29. So they are unlike terms, but we can find a way to combine them so that it shows the operation. So x equals to a minus 5, negative 5, plus and minus square root of 29. And that's your final solution. Okay, so this video involves completing the square and show you two types of examples in the form of x squared plus bx and also x squared plus bx equals to some d value. I hope you enjoyed the video. Please join me again in the quadratic series, and we'll show you more examples of completing the square. In the next video, we will find the maximum and minimum of quadratic equations. Thank you, and you have a good day.